Well, we are on chapter 10. This is the one about SQL databases. And I would say this is probably the most immediately practical. So if it's like you're just getting started, you want to apply these principles, it's like, okay, you can apply these principles to the application that you're building right now on top of a SQL database, and you can have some success. So precisely the sort of patterns that we're using on my current project. And if you happen to have caught a talk that I did and recorded a while back called "How Not to Destroy Data," it's basically these patterns. So of course it's got the clickbaity title that all talks have to have. But yeah, so the idea is that you can select, you can insert, but you cannot update, you cannot delete. So those are disallowed in the SQL database. And in fact, the way that I typically set up my security is that the connection string that the application uses allows select, insert on all tables, but no update, no delete, and of course no DDL. And then so if you need to do database migrations, that's a different connection string, and that one's got everything it needs. But application cannot destroy data. And so taking just the security aspect of that just means that if somebody were to take advantage of a SQL injection attack, then they would be able to create new information in your database. They would, of course, be able to see all the information in your database, but they wouldn't be able to override anything. They wouldn't be able to update and destroy the data that's already there. They wouldn't be able to delete anything. So using some clever forensics, you could go back and clean up the mess that they made. But yeah, the real motivation is not so much the security, but the immutability, the advantages that you gain from having immutable data. And one of the first advantages, the things that people talk about most often, is that now you have an auditable log. You can see exactly what happened over the course of your application. So that's an advantage that's been talked about for event sourcing and other append-only solutions. So we get that one. That's cool. The patterns though that you have to use in order to use a SQL database in a historical fashion are a little bit different, a little bit wonky. Foreign keys. If you've got a single predecessor, now a foreign key is a reference to your predecessor. That's nice and easy. If you have multiple predecessors, that's where it gets a little bit wonky, and that is that you have to have a child table that represents predecessors. So you start going in the opposite direction. But yeah, once you kind of get your head past that, then the patterns start to make sense, and you start to see some advantage from them.
To what extent do you model, like earlier in the chapter, you're kind of moving towards the more generic way of storing. Do you sometimes do both? Do you sometimes still make tables that are more specific to a particular fact type, or have you generally leaned more towards the generic approach?
Yeah, I lean toward within my application database. I stay strict historical, and enforce that, like I said, by the connection string only being able to do that. But then where I need something that can be mutated, which is good for performance, good for reporting, good for search. So there are some needs for that. Then I will use a different data store for those things. So,
sure. I think I was unclear on my question. I was talking about early in the chapter, you're modeling table per fact type, but toward the end of the chapter, you get to a generic fact type or fact table.
Yes.
And I'm curious, do you still do both, or do you generally just say everything works great by just using the more generalized approach?
Yeah, so I will usually, for an application that I intend other people to look at and not go completely insane, I will go with the application-specific database, so table per type. And so they already have to get over the fact that there are just a lot of tables. That's kind of what this leads to. Is that, yeah, every decision that a person can make is a fact and is a separate table, whereas in most systems, a decision that a person can make can create a new record or update an existing record, or so it can do lots of things with the existing things. And you can have like some nullable columns in there. So when somebody pays your invoice, okay, you will go ahead and put the date paid into that nullable column, all that fun stuff. But I'm like, nope, everything is a separate table, so you just end up with a whole lot of them. You end up with these deep joins, lots of foreign keys. People get sometimes bent out of shape out about that, and then, well, let's just take a look at the query plan. You see, it's not too bad, and so profile it. If it gets bad, then.
Well, I imagine with the generalized model, you can get a lot of recursion, which could have its own pros and cons to that. Although, I guess I'm curious about this. Like maybe in the book you talk about distributing facts and maybe limiting what you share and things like that. And maybe the closer you get to the application, it sounds like that's where it makes sense maybe to do the more fact type or table per fact type approach. But maybe if you're doing sort of a more as you get closer to maybe a centralized place, not losing location independence, but like the big metal that's going to store everything for every mobile device or for every app user out there, maybe moving more generic there. And then I imagine you could just Redis cache the heck out of everything, so you can persist it, but you can also just memory's cheap, so just throw it out there. And I don't know, that's kind of something I had in mind. Does that sort of gel with maybe your thoughts are heading?
Yeah. So where I reserve the application agnostic databases for things that I'm putting an immutable runtime on top of. So Janaga is backed by an application agnostic database correspondence as well. But if I'm not using a Janaga or correspondence or whatever other thing will come to fill this space, then using an application agnostic database gets kind of tricky. And then, the things you were talking about, like, you can optimize performance by doing the Redis caches and stuff in front of that. Absolutely. And I want the application agnostic runtime, the immutable runtime, to participate in that. I want it to know what's being cached and read through the cache in order to get things, because you're basically relying upon the immutability in order to make those caches work better. So if you know that you're reading immutable data, then you know that you can invalidate the cache, because the cache usually doesn't store the raw facts. Because if that were the case, then the raw facts don't change. You just have to notice, hey, there's a new fact. Let me go ahead and store it in the cache. But if you were querying the cache of raw facts, you would basically end up doing as much work as the database is doing in order to assemble a projection from a set of facts. And so, you'd be doing that in something faster, so you might gain some performance that way. But the best way to really optimize the application is to cache the projections. And so now,
that makes sense.
You're running the query inverse operation in order to determine when the projection needs to be updated. And so the immutable runtime participates in that. It says, oh, new fact, query inverse. Oh, that needs to be updated. Let me run the query, put that in the cache, and now it's available downstream.
Yeah, I know it's less about SQL, but it's like optimizing your SQL to some extent. But my thought too is you just do a even if it's doing on the querying of your facts, as long as you're, caching recently read facts, almost like an identity map, in an ORM, something like that. So if you're regularly, grabbing the same fact, you just kind of, and then it sort of fades out, maybe like with a time, kind of like how CPU caching works, right? It's just like the most recent things are the things that are going to get cached, and then everything else is going to kind of fade out.
Mm-hmm. Yeah. And in fact, in Janaga, I do use that technique for there's a distinction between running a query, which really should be running a pipeline. That's one of the Janaga defects that I noticed while writing the book. But you send a pipeline to the server, and it gives you back the results. And now the client and the results are references. They're fact type and hash it. So it's like these are the facts that you should know about in order to satisfy that pipeline. And then the client is like, well, I already know all these. Oh, but these few I don't know about yet. So let me go ahead and load. So it does a two-step process in order to avoid just sending all of the results as fully materialized facts. So in that process of loading, now the server is able to use its in-memory cache of those facts and say, well, I've already got it. I know it's not changed. It's a fact. So just send it back. But if you're talking about doing a successor join, then new successors might be there. So you have to.
Michael, but by not using the application agnostic database, you lose the most important advantage that versioning becomes easy.
Yes.
Or easier.
Yeah. Easier.
Mm-hmm. Yeah. Versioning is a hard problem. I definitely wouldn't ever call it easy, but
and that's true for everyone, not just this, right?
Exactly. Yeah.
Could you explain this versioning thing? And I mean the last 3 pages from this chapter, because I understand that it's like concrete. Yes, it's like ledger from the cryptocurrency. That's everything we touch, we change the hashes, and everything is broken. Yes, if we want to change something from the past, we need either to add some successor, represent new field, if I understand correctly.
Yep.
Or if we want to add some field, maybe to existing fact, I understand that we need to create completely different path in this tree to replace existing one. Yes.
Yes.
And we store some versioning hashes, etc. And we got completely new path in this tree. If we ask for this new path, we got this one. If we ask for the old one, we got the old one. But if we want to add maybe some step in the process, in the middle, how to handle that?
Yeah. When you do need to change the structure, and like you said, you need to change the structure a little bit less often than you do in a static database, because you end up with smaller facts, and you can add new properties by adding new successors, and they're not actually part of the fact because they mutate. You do end up doing it less often, but you never get away from that need. So I have had plenty of models that after version 1 I realized, oh, this is a successor here, and it really should be up here, and there should be something else going on, and need to refactor. So that definitely happens. And when it happens, the strategy that I've adopted is the facts that you recorded in the past are facts that you're not going to change their structure at all. So you're going to define effectively a new fact that has or a new fact type that has the structure that you're looking for. So in the case of let's suppose that you had a going back to the customer order kind of thing. Let's go with speakers. I like that one. So you've got a a presentation and a speaker as a successor. Actually, let's do it the other way. So the speaker is the predecessor, and then the speaker can do a presentation. So that's the successor. So now you live in that world for a long time, and then you realize, hey, there are some presentations where people are co-presenting, and so that strict presentation has one speaker relationship doesn't fit. So you just refactor that one into a presentation has many speakers, or that might get to a separate presentation, and then you can add and remove speakers by having successors there. But let's go with the simple one. You just changed a single to a many. So now in that case, you have changed the structure of that fact. But the ones that occurred in the past, you can't change their structure. They're immutable. A change to the type is a change to the fact, and we're not going to allow those. So so you end up with two different structures, and they both have the same name in our source code, but they are truly different structures. If we were to think about kind of looking under the compiler, maybe the compiler is coming up with a fully qualified name, which is presentation underscore and then a whole bunch of hexadecimal digits. So so imagine that the compiler took the fields of presentation and hashed them in such a way that that if there's one speaker, it gets one number. If there are many speakers, it gets a different number. So now you've got two different version numbers of that class, and so that's the structural versioning idea, is that you don't capture within the version number which one came first. You don't serialize them. You don't say this is version 1 and that was version 2. The reason being that we are participating in a distributed system as developers too. It's not just the systems we build, but I'm going to make some change to my source code, and so I'm going to come up with a new structure for the fact that I call presentation. And so my structure now is going to have a new version number. But I can't say mine's version 2 because you might come up with another one you don't know about mine and you call yours version 2. So instead we just hash the structure, and that hash of the structure is the version number. So,
what would you call it though in your actual, say you're in TypeScript and you already have a presentation fact type? And I know that it's not the fact, right? It's the structural representation in TypeScript of how to interact with that fact. So is it okay there maybe to call it, presentation and presentation v2, just knowing that under the cover? Okay.
Yeah,
but exactly. You'd want that to be serialized as the fact type presentation, not as presentation v2 when you store it in your actual historical model.
Yeah.
Unless it's a totally different thing, right? I guess it's like, are we really trying to take presentation? I guess, is there a spectrum between I'm taking an existing fact type and I'm modifying it, but it's still basically like this happens in event sourcing too, right? This is a modification. This is basically a mutation of the shape of an existing event type. And sometimes you just say, forget it. We're making a totally new event type and it doesn't have that history behind it. So how would you kind of recommend deciding when to do which here? Is it similar to what you do with event sourcing?
Yeah. I think it would be similar, is that you keep the same name if it has the same intent. And you really just want to evolve that structure over time. And now you're using the version number as it should be a part of the serialized fact. So it should know that I'm presentation x5397 versus presentation yzx. So yeah, the serialized version, the serialized fact should know the structural version of the fact type that was used, and your source code can now recognize that, oh, that structural version maps to what I call in source presentation v1, and that one maps to presentation v2.
Yeah, and you make a good point that I think, at least I want to highlight, because they sometimes can fall out of my mind when we're thinking about this stuff. But basically the idea is you could get facts that you don't know exactly what they are, but the structural type will be there, so you could derive it. So it's possible that if say you do have a static model on top. When I say static, I mean like classes and stuff like that on top of a fact, historical model. If you start getting facts you don't recognize, you could still go in and you could actually make a type on top of those now and actually start interacting with those facts. But people don't have to wait for you to do that to start introducing the new facts, which is, boy, that's really cool. You just have to be able to get facts you don't really know what to do with and just like, well, I don't know how to deserialize this, so I'm just going to move on, right? Yeah. Okay, that's really cool.
And in an application agnostic database, you can go ahead and store them. I mean, if you don't know how to deal with them, you can't run the authorization rules on them. So, so maybe you don't want to.
And I was going to ask you about that too. So speaking of like the application agnostic database and stuff like that, so now you want to retrieve these facts so you can actually do something with them. It seems like, and I'm thinking about distribution rules as well and how this all works. So as I'm loading up facts, I'm thinking, do I need the entire transitive closure every single time? Well, if I have an abstraction that's just, something called fact, right? Literally, it's called fact. Well, yeah, that can have an abstraction. It can have a thing called like predecessor reference, which just has, the ref hash in it, but it doesn't actually have the full predecessor, loaded into it. But if I'm then actually wanting to deal with the entire transitive closure, I need every fact. But what if there's a cutoff point where I'm saying, I don't want this distribution rule to include predecessors prior to this certain, in other words, it's like a cutoff point on the transitive closure. Is that stuff you've dealt with, and how do you kind of work through those sorts of situations?
So this is one of those places where it's a bit of a cheat, but it's a cheat for a good reason. The authorization rule, when you receive a fact, when you first learn about it, you run the authorization rule. If that allows it in, then it is forever authorized. So there is no revocation of authorization from that respect. So you can, of course, revoke authorizations, and now from that point forward, if somebody receives it, then they will not accept it. And the reason that's a cheat, and a pretty big one, is that now that has broken eventual consistency.
Yeah.
So based on the time that you pulled it and whether you knew that somebody had revoked that certificate, you can no longer, you don't see it, but somebody else already has accepted it. And that's one of those places where I had to kind of be okay with it, because to run the authorization rules of the transitive closure is just a huge explosion. So every time you receive something, you would have to say, well, okay, I need to make sure that all of its predecessors and their predecessors are still authorized. And then not only that, but also the facts that I use in order to check whether you're authorized, they themselves also have to still be authorized now. So basically the cheat is once it's past the authorization rule and it's in your local storage, then you can use that for future authorizations. Yeah,
that makes sense. Now, what about distributing to say I've got a mobile device and I've got a user fact, and I want to allow the user fact to flow out to that, but I don't necessarily want information about, say, the subscription that user is a part of to flow out there. And my first thought is, well, if subscription is just a high-level object that just has like a GUID in it, okay, they can get that. Nobody cares. And then if it has successor facts below it that kind of define the subscription information, great. You just don't include that. And maybe that answers my question, is just kind of, as long as that subscription fact doesn't include a bunch of stuff you don't want distributed, then you're fine to distribute it. And any successors you just don't include when you ship those over the wire.
Yeah, exactly.
Okay.
So you don't put them in your distribution rule. You don't authorize those clients in order to create those successors either.
Yeah, and I think that helps explain a little more the utility of having those. You mentioned this in the book in an earlier chapter about when to use GUIDs, and you said something along the lines of the best place to use them is very top level facts. That just there's really no, like tenant is a great example to me. That's not company, that's not enterprise, that's not organization. It's a very abstract concept that you can attach users to through a subscription or with this sort of a thing. So yeah, you throw a GUID on it and then you just distribute it. Nobody cares. It can just go all over the place.
Yeah, exactly.
Yeah. Okay. Yeah, that's cool.
Awesome. Well,
Michael, for the versioning, what would stop us from, if we have the old model, we have a new model next to it, and we would transfer the old model one way into the new model, meaning that the old clients, they keep on the old model. People who use the new client application, they use the new model, but they get the old facts that are still coming from clients who have not been online. It comes in, it get converted one way, so they get the old facts as well. Of course, all the hashes will be recalculated on the server. All the facts will be mutable for a while in the server, because we are making them from immutable into a new immutable structure.
Yeah, you're projecting. To use a different term, different use of the word projection, but it's a function from one to the one space to the other.
Yeah, it's a one-way function. The only restriction I'm thinking of is you cannot encrypt your facts, because then you have a problem. But the whole structure, including the hashes, have to be recalculating. Would that be a solution, or?
There are a couple of issues with doing that, and it's possible, although it's something that I've not done because of these issues. One is signatures. So if some other system has some other user has created that fact, and so it's signed using their private key, so you can verify it with the public key, but you yourself are not the key store, so you don't have access to the private key. So when you create that new fact that represents the same intent as the old one, then you can't sign it with their private key anymore. So so now you have to say, well, okay, this I'm going to authorize this surrogate that's doing all of this translation for me. You might be able to do that. The second caveat is that one-way function needs to be deterministic, basically, in order for it to be map each fact onto a new fact, it would have to use all of the information from the original fact structure. So.
Yes.
There are some restrictions to that function, but if you do that and you so let's assume that you don't have any signatures. This is just a wide open public, anybody can do anything system, and you've got a one-to-one mapping. So it's onto, and it's injective and bijective, whatever. So assuming that's true, then it's actually possible for you to be running this translation function on multiple machines and still converge. But if you don't have it be a deterministic thing, then that means you can only run this on one machine, and it had better not hiccup and do something twice. So you end up with location dependence. But as long as it's bijective, then you maintain that. Yeah,
you are location dependent, but it's only for a while. It's just until the moment that all your old clients are upgraded to the new version. So
this is one of the reasons.
One hour, 1 month, 1 year, but it's It's limited.
Yeah. I don't know how long
That's one of the reasons I introduced an idea of I'm calling it model, which is basically a collection of fact types that you can define together.
Mm-hmm.
Because my thinking early on was, especially early on when things are still kind of unstable and you're figuring things out. Let's say you put a ton of work into generating a bunch of data in your first model with a bunch of fact types, and then you just say it's going to be too much of a pain to try to version all of these things, and we haven't even shipped yet. Like, you don't want to ship versioned fact types, when you haven't even shipped version 1.
Mm-hmm.
So my thought there was, what you do is you just create a new model, and then you create mappers that basically say, take all the facts from model A, and then you map them into fact types in model B, and then you can basically just say, now we're using model B, and everybody starts talking to that, and then you could even throw away the stuff from model A if you want. But especially if, as you're in early stages of development, you really want to iterate quickly. You could also, do that in production. You'd have to realize now that everybody is going to have to switch over, and you're going to have to, maybe even support both models for a period of time, which you could do, right? You could do dual writes to both models for a period of time until everybody has cut over. And so there's various things you could do along those lines.
Yeah, but the moment that you release an update, you send a message to the old model, to the old clients. They get a message box. Look, there is a new version available. And if you continue to work, you will not have all the information.
Yeah, that's right. And in fact, you could, and even there, you could even embed that in your model, right? Let's make the implicit explicit. So maybe you have a fact in your model that you say, new version, new model is now available, and this model will be deprecated as of this date. So make sure you switch over. We're getting into really esoteric stuff now, but I mean, these are also the nuts and bolts when you're trying to do this stuff in real time. So I stuck a model table in my Postgres. I haven't built it yet, but as I'm playing around with how I would store this stuff, that was just one other thing I added was, let's have these fact types all be part of a model so that I can iterate in a different dimension if necessary for a couple different reasons. Right? Early on, iterating when you're trying to just be agile, and then later on, even in production, if you for some reason just need to say, we did it wrong, or what, that also gives you a chance to purge facts if you need to. So let's say you got to shred some things, or like PII, like maybe something like this. There's other ways to do it, but
because the only thing we certainly don't want is that. For example, a mobile client who has been on holiday for a month and he comes back and he hasn't synchronized all his work yet, that these facts get lost. So that's why
So now you have two facts in model A. One is this is going to be deprecated as of this date. So make sure, if you get the deprecation message, you're good to go. And then the next one is it's going to be locked as of this next date. So it'll still be there, though. And then maybe it's after that. So deprecated, locked, and then it's like it'll be purged as of this date. So yeah, some poor person that spent a year, sorry, you're out of luck. You're just the time card that you put in last year, you're not getting paid for. Sorry, dude. You right, or whatever.
Yeah. Yeah, so just want you to recognize that these solutions are based on a known topology. So, so like when you're talking about you have a bunch of mobile clients and they're all talking to the same server. Okay, you know that topology. You know that everything's going to flow into the center and then back out to the others, and so you can start to put those gates in there. I'm going to do the translation here. I'm going to use the time according to this machine. So you're kind of baking topology into the solution, which is okay if you recognize it. So that's. I was talking with some friends and about this, and pretty much they made the observation that if you run into a problem here, it's because you were going to run into that problem. This just makes that problem hit you in the face sooner. So you have to pay attention to it. Versioning your models, that's always going to be a problem. So my preferred solution is simply that the client honors the old and honors the new, and so you don't do any translation from old to new, and so if that's hard. That takes work on the query side, and it takes merging of two different projections into the something that looks the same to the front end. But if you do that, now you're solving the problem without taking a dependency upon topology, and not having a process that's got to be running in a certain place and have those.
Yeah, that's right. And I think migrating models early on, fine. You haven't gone to production, go for it. This is the kind of thing I think you'd want to measure in years to decades, right? Not in weeks or months. You don't want everybody moving to a new model every few weeks. But if after 3 years it's just versioning is killing you, it's getting really hard. The projections are so just difficult to get your head around. Maybe at that point it's time to say, okay, and of course, knowing your topology, knowing your SLAs too, right? If you have certain SLAs about guarantees of what will and won't be committed and this sort of a thing, okay, then you, according to your SLAs, you make that all fit. But yeah, definitely not something you want to do without some serious thought and and design.
Yeah, and I'm kind of curious what constitutes the boundary of a model. So you say, okay, we're iterating on this model, and so we're adding new facts to it, and then we say, okay, we're abandoning that one, or we're deprecating that one, put the timestamps and the migrations in place, and here comes a new one, and we're starting to iterate on this one. So are there some facts that are the same between the two? I would imagine that there are going to be quite a few.
I would say so, and that's why I have explicitly avoided putting anything about model into the fact type, because that would definitely cause issues, right? So I had that same thought. If you put model into fact type, now it's owned by that fact type, and it's going to be unique for every model. But I did want different models to be able to share the same fact type, which of course would mean they would then also have to share all of the predecessor fact types for each of those as well. So but I was also trying to make it abstract enough that you could decide, what you want a model to be. I mean, I was even possibly envisioning you might have, two models running side by side in the same application. Say you've got some identity and access stuff that you want to be able to synchronize up some, authorization privileges that are more like app based. Can the user click this button, or can they this or that? Yeah, maybe that's a different model from your core business model, right? So, and that would be kind of maybe a distinction to make between more infrastructural application type concerns that are less businessy, and then maybe the more nature of the workflows you're trying to do, the business problems you're trying to solve. Again, just an idea, but I was looking for something that's abstract enough that you kind of, a model is whatever fact types you put in it, and they can be fact types from another model, they can be unique to that model, or it can be a way to migrate from one model to another, whatever you decided you want to do. It's just an organizing concept, right? That's basically all it is, and it's not really meant to affect the fact types or the versions or anything at all. It's just a collecting principle, but you can use it when you're querying. You can that was it. That was the idea.
Cool. Yeah, so I know, Luke, we went all over the place, starting with structural versioning. Did that address your core issues there?
For me or Jan?
For Luke. Luke was asking about structural versioning.
For Luke,
I think I understand it now, because if I understand you correctly, Michael, we have some structure, yes? And even if we want to add a fact in the middle, we still need to recompute part of this path that comes next, yes? Everything that was before stays exactly the same. We end up with a branch in this tree. We have a version 1 of a fact and the second version, yes? But this second version points to this fact in the middle, yes? So everything is, like you said before, we end up with having both models. But it's up to us that we can now query this differently, yes? We can start from the top of the tree, from the bottom of the tree, but because everything is hashed, they are different hashes, yes? And we can got this data we are interested in. from the old model and from the new model.
Yes.
From maybe for the old client, we will be asking this first branch, but we could go to the second branch with this new version of the application. We don't even need to use version numbers because we have identity in the fact itself. Yes. So we can start from both directions. For the second branch, we need to create a completely different query because this new fact goes in the middle.
Yeah, you definitely would need to change the query based on that structure. And so, the mechanism that I like to use is you keep the old one and you use the new one. So you're running both of those queries in the new client, and the reason is that the client is still accessing old data. So the old client is just running the old query using the old structure, but the new client is running both of those queries, and then so computing projections for each one. And now I have that be a concern of the client as it's consuming that projection to merge those things. So you get some child objects from the old model, some child objects from the new model, and you just put them into you project them both into the same view model in your client, and you put them in the same array, and so now it sees all the same things.
So the pressure is now on the querying side. So we need to create for two queries and union them to get results we are expecting.
Exactly.
But it's still much simpler than to create different versions and mappings between those versions, etc.
Yeah, I think it's ultimately simpler than migrating the history of facts from one version to the next. It's you have to eat your spinach somewhere, and so just eat it on the query side. But one of the mistakes that I made in correspondence in particular was that there was no projection layer. There was nothing in between the query that you ran and your user interface. So I would just write my view models to as just regular C# classes to talk to these facts directly, which meant that when I had multiple versions, the view model now was running multiple queries and doing all that merging. But with the addition of projections, then now we can project two things into the same shape, and the merge becomes easier. And then so that gives us a little bit more support for it. But that's still a feature I haven't yet to build into Janaga, and I need to really test that out to make sure that that's going to work. But in one of my Janaga applications, I did actually do a model change in the past, and for the longest time I was running two different queries and then just doing those object merges in JavaScript before I presented them on the user interface. And now enough time has passed, enough clock ticks have gone by that I know that my queries for the old data model are going to return nothing because people have been inserting new facts according to the new model. So these clock ticks are only populated on this side. And so I have been able to retire that old query code in the clients. So now if I were to point the client at a previous clock, at a previous period, it would be empty. But nobody's doing that. So we can evolve our applications. Just have to be careful how to do it.
Nice, thank you.
Cool. So we talked a bit about structural versioning and application agnostic versus application specific databases, and then also the fact that some data stores are better optimized for reading a projection more directly, and so those tend to be better served by a static database that's backed by a historical database. So, any other points before we start to wrap up?
Michael, the nice thing about historical modeling is that we have the whole past now. The only thing, it's not really a temporal database yet, yeah? And for sure not a bitemporal database. So for temporal database, we need the date that the information is added into the database. For a bitemporal database, we need the date that the information is added and the date that the fact will become valid. Yeah. For example, somebody is going to move to another town. He will go to at least in Belgium, he will go to the town district, to the head of the town, and he will register himself in the new town, and he will say, okay, from that day onwards, I will live in the new town. Yeah. So you, for example, today it's the 22nd of September. Yeah, 23rd of the September, he goes to the head of the town and he says, okay, from the 15th of October, I will live in that new town. So,
and we just use periods for that and create future periods.
I think we have to add the transaction date, the date that we add the information, and we have to add the valid date, the date that the information becomes valid. Because what we have now in our model, you can have conflicts, two people who change information without each other knowledge, then we have a conflict, but it's more like a correction. Yeah, somebody entered something and it was wrong, so somebody else is gonna enter it, and it has that new correction has always been valid. But it's not like it started from a certain point in time. Yeah. For example, now I go and tell the head of town, I will be moving to your town 15th of October. And by the end of the year, I go back and I say, sorry, I was wrong. My plan changed and I only moved the 1st of November. So they have to be able to correct past information. And we already have all the information in the historical model. It would be very nice if we could add this temporal or bitemporal aspect to it.
Yeah. Could you use a mute? I mean, it depends on, I don't know your model, but I mean, if you had a mutable type, then you could change it. What I guess it comes down to, do you need to be able to query for those facts explicitly, those dates explicitly, and make them explicit facts, or are those fields within, and you'd query them through projections rather than querying them directly through the fact model? So are these explicit types, these dates, these validity dates, or are they properties?
I think the transaction date, so the date that you added to the database, should definitely not be part of the identity of the fact. Because imagine that you add a fact, something happened, something happened, you add the fact, and somebody else add that same fact tomorrow. It's still the same fact. And it was already added today, so it was known. So the second fact, which is added tomorrow, doesn't matter anymore. So it should have the same identity.
I mean, if it was mutable, you could reconcile those, either at runtime, or you could make a new fact and pick the one, or whatever you want to do. But it sounds like you're talking about something that's not a mutable type.
Yeah, and I think that what Luke was saying about using the period pattern, that makes it an explicit separate fact, and now something that you can query the system on. So if you have discrete period boundaries. So you're going to have one per day, for example, and now you're sending somebody their mail. So it's like, okay, what's their address today? So I start from the today period and query down until I find people's addresses, and now I can say, well, he's going to be moving in 13 days, but I don't care about that. I'm just looking at this period. If it were more of a continuous time frame and you couldn't have those discrete periods, then you would want to have it be a mutable property attached to the fact, and now you're just querying all of their addresses, and now in memory you're saying, okay, these are in the future, so this is the most recent one in the past, so that's the effective one.
Yeah, but we could perhaps even combine the idea of Luc and the idea of Jeff. For the rough selection, you use the period pattern, and then for the fine selection, you could do it, the filtering in the projection, like Jeff said.
It's possible. I mean, just realizing that it is possible that the date in the projection may not map directly to the period as you've conceived of it. But this is the thing I realized. I wish I'd learned this a long time ago, because when I was building a labor tracking system, we were trying to map to payroll periods. And then I read this book and I went, oh, there it is, right? You just have a payroll period. And it doesn't have any dates in it. It just has a name, right? It's period 1 of 2020 or whatever you want it to be. And then you map to the dates later. So if you get a time card, clocked in that's in for that period, but it's for out of the date range, you don't care. You put it in there and you run it, and it's part of the payroll, right? You're fine. So it's like, oh, I wish I knew this when I needed it.
Yeah,
I think that the transaction dates should be quite easy to incorporate into the model. Really, the valid date or the effective time, I think we have to think more about that.
Yeah, I think you have to. Well, you have to analyze your problem domain and make the appropriate decision for your problem domain, and then you can model it historically. So you can model it as a period. You can model it as a mutable property. So that's one of those those things that I would say is above the level of the concrete. These are the things that make the math work. And then above that, you've got the patterns that
well, it's the pattern for that we should work out, because I think that a lot of people are looking for that, and then temporal databases is something very, very hard. So if we could solve it with historical modeling, that might be interested to a lot of people.
Yeah, I think so. So that would probably be a pattern in Chapter 8 in the second edition.
In the patterns. Now, anyway, I need part of that for my mobile application, so I'm thinking about it. I have no choice.
If I might advise you something, maybe some example business application with common problems will be super idea.
Yes.
Show how this enterprise system could be modeled like that. With versioning, with mutable properties, etc. Would be nice, because I read the whole book and it's full of math. And
you're welcome.
For some people, maybe a little bit too much. But if it will be some example showing this in practice, not like simple. Like exercises like a chess game or something, but
right.
more advanced. Yeah,
I fully agree with you, Luke.
Yeah,
I agree too.
That's what I would love to see happen on the Janaga GitHub.
Let's work on that. Let's work on that.
Awesome. Well, thank you all for joining me for Chapter 10, SQL Databases.
Thank you.
Yeah, and so next week, same time, same place. I believe we're starting to get into some pretty cool stuff with, so we're talking about the communication patterns, so HTTP RESTs, queuing, all that fun stuff. So, How do we map it to that?
And then the book is almost finished.
Yeah, and then I don't know, take a break and start another cohort if there's some more folks that want to join in, or see where it goes.
Oh, then we can really start making the models like Jeff is already doing.
Yeah. Cool.
So, okay.
Yeah. I'm looking forward to it.
Bye-bye.
See you next week.
Everybody.
Bye-bye.
See you.
See ya.
Bye-bye.